Okay, so this is section 1-2. We're going to go ahead and graph an equation using intercepts. And so what we need to do to understand how to solve this problem or to graph this is actually a very easy way to graph lines is to use the intercepts. So we know that if I am let me change the thickness here. Okay, if I am a y-intercept, that means that x is equal to 0. Because when I'm a y-intercept, I'm on the y-axis, which means that all my x values are going to be equal to 0. Okay? So now, when I'm an x-intercept, my y value is equal to 0. So if we look at the graph, right here is the x-axis. All my y values are 0. There's no height to it, so there's no vertical change. So y is going to equal 0. So what I do in order to find an x-intercept, I'm going to set y equal to 0. And so I have my equation, but I plug in 0 for y. 2x is equal to 6. And so we divide by 2, and x is equal to 3. So what that means is now is that I have the point 3, 0. And I'm going to go ahead and plot 1, 2, 3, 0. Now I'm going to do the same for my y-intercept. So my y-intercept, I know x is equal to 0. So that means I'm going to take my equation, I'm going to plug in 0 for x. That cancels out. I have negative 3y is equal to 6. I divide by negative 3, and y is equal to negative 2. So my y-intercept is the point 0, negative 2. I plot that point, and I go 0 for x, so I'm along the y-axis, and I go down 2. 1, 2. I plot the point, and I connect my two dots. And there's my line. And that's how I would graph using intercepts. It's a very easy way to graph a line. We don't have to worry about slope-intercept form if I'm just graphing a line in the format that it's in right now, in standard form, where the x's and y's are on one side and the constant is on the other. I just plug in a 0 for each variable. That gives me the intercepts, and then I'm able to actually just graph a line with no manipulation of the equation. Just plug in 0. It's more efficient, and it's a lot easier to do.